Good morning. Today you will be learning 7.2a, multiply monomial by polynomial. Your learning target is basically the same. I can multiply a monomial by a polynomial. Okay, so monomial means a single term. Polynomial means multiple terms. So if we read down here, it says to multiply a monomial and a polynomial, simply distribute the monomial to the polynomial. For exponents, recall the product rule. So we're going to go back to what we learned a couple weeks ago. We have the product rule. If you have a base and exponents, and the bases are alike, you add the exponents. So we're going to use this a lot again. So if you're struggling the first time, you get another chance here. So here's our example. We have to distribute. The only thing that's different about this is the fact that you now have variables, okay? We had used variables before too, so it's not super crazy new. We take x times x. Remember, there's ones here. You add the exponents. This gives us x squared. And then you take 4 times x. You can't do really anything with that, so they just become buddies, 4x. And that is your simplified answer, or your multiplied answer. We can do the same thing on example 2. We distribute. This time it is 5m cubed. So you have to take the 5 multiplied by the other big numbers. So 5 times 3 is 15. And then you have to add the exponents. M cubed times m squared becomes m to the 5th. You do the same thing with the remaining ones. We have negative 5, because there's technically a negative 1 here. M to the, add 3 and 1, you get 4. And then you multiply m cubed, 5m cubed, times negative 7. So you get negative 35m cubed. Now we've discussed making sure everything is in standard form, so the biggest exponent to the smallest exponent, and these are already in standard form. We don't have to rewrite them, so we're good to go there. All right, so as it says here, find each product. So you're multiplying, you're distributing. Final answers must be in standard form, like I was just saying. So we'll do the odds together, and then I'll give you guys time to try the evens. So for 1, we distribute k through. This is really similar to what we just saw in example 1 above. We end up with k squared minus 9k, and that is in standard form. All right, go ahead and pause the video. Try question 2. Okay, hopefully you're ready. You go ahead and distribute. Guys, it's distributing every single time. Anytime you see a monomial, single term outside of the parentheses, and it doesn't have another sign, you probably are going to distribute it through the parentheses. So you end up with 9a squared plus 9a. Still in standard form, so we're good to go there. Okay, let's do 3. Once again, a simple monomial distribution. You go ahead and distribute this negative 6 through. So multiply big numbers times big numbers, add the exponents, so that's technically p to the first here. We get negative 6 p to the 5th plus, because two negatives make a positive, plus 48p. Pause, go ahead and try question 4. All right, hopefully you're ready for question 4. We go ahead and distribute this through. It's going to become very repetitive, guys. It's the same thing over and over. It's just helping you remember the product rule that we learned a couple weeks ago. So big numbers multiply. We have -6, c to the 6th, and -15c to the 5th. Once again, in standard form, so we're good there. Question 5, distribute. My bad. We end up with -8 g cubed minus 28 g squared. Try question 6. Does look a little different. You're just going to distribute 3 times instead of 2 here. All right, let's do it. We distribute to the first term. We get x cubed. We distribute to the second term. We get -x squared. We distribute to the third term. We get plus 3x. All in standard form. Good to go. Question 7. Same idea. 3 terms in the polynomial to distribute to. The first term, we get -3n cubed plus 6n squared minus 24n. It's just piece by piece, multiplying each individually to come up with a new polynomial. Try question 8. All right, let's do it. We distribute first term times monomial, -12 x to the 6th, because 4 plus 2 is 6. Distribute to the second term, 24 x to the 5th. Distribute to the third term, -36 x to the 4th. All in standard form. Okay, now we're looking at something new down here. You guys notice how there are 2 variables instead of just 1? That's fine. We can still distribute this. Okay, we are looking for things specifically with like bases. So when I distribute this through to each, the p's bases will add, exponents I should say, and the q's exponents will add. So we will get p to the 7th because 2 plus 5 is 7, and q to the 5th because 3 plus 2 is 5. Okay, you distribute to the next one. These are both 1s. This negative in front, guys, doesn't really matter. It's like 1 times -1, so don't think about that as being anything with the exponents. The exponents are separate from the negative in front. So we get p to the 3rd and q to the 4th. These are a little trickier to put in standard form, so we'll call it good here. You guys try 10. I know it's a little bit new with these multiple variables, but I think you can do it. All right, so 10 even looks slightly different because when you take this times just x squared, the only term in the monomial that will end up changing, in quotes, is the x, because it's the only thing with a like base. So here, for the first term in the new polynomial, you get 3x cubed and then y. So the x is the only thing that changes. Then you distribute it to the next thing. You have an x and a y, so you end up with plus 3x squared y squared. And then you have a y squared down here. So the y is the only thing that's going to change. We have 3x y cubed. And once again, standard form is a little trickier when you have multiple different variables, so we'll just keep it. Okay, question 11. Once again, we distribute. You should notice this every time. It's on the outside of the parentheses. So you will distribute it through to each term. Big numbers multiply, so we have negative 10 because of 5 and negative 2. And then you have r squared and r squared. You add the exponents. These become r to the fourth. S squared has no buddy. It stays. Go ahead and distribute to the next one. We have 15 r cubed s cubed. We have, for the third term, negative 20 r squared s to the fourth. Okay, you're just adding your exponents of like bases and multiplying big numbers. Try 12. All right, on 12, we distribute. We get 12, because the big numbers multiply. A to the third, 1 plus 2 is 3, and B. For the second term, we get negative 21, A, B to the fourth. Okay. Question 13, distribute. This one all has a little bit more, it looks like, going on, but don't freak out, multiply. We have negative 63. C to the fifth, D to the fourth, because you add your exponents. And then, we have positive 28, big numbers multiply, C to the fourth, because there's a 1 here, and D to the seventh. I probably should have mentioned before that you should make sure that there are no like terms to be combined as well, but there have not been. C to the fifth, D to the fourth is not the same as C to the fourth, D to the seventh, so you leave it, okay? There might at some point be terms that you need to combine, but for now, we don't need to do that. Lastly, make sure you've paused the video. Try 14. Okay, hopefully that was enough time. Go ahead and distribute. Big numbers, you get negative 20. 10 times negative 2. Then you have m to the fifth, n to the fourth, because you add your exponents of like bases, plus 30, m to the fourth, n to the second. All right? With any extra time, guys, I would like you to go ahead and work on, let's see if I can pull it up, this worksheet. It's the next page in your packet. Maybe. Okay, well, apparently it doesn't want to pull up. Just flip your page over in your packet, and it's homework 2, monomial times polynomial. You guys can do questions 1 through 9 perfectly. Actually, 1 through 8 perfectly fine. So go ahead and try those if there's extra time, and have a great day.